Hey, welcome back for the second half of session 4. In terms of what we're going to be doing now, we're going to start taking the whole notion of adaptive components and the ability to kind of reshape things and see how we can apply that when we have different curves, things that are a little bit irregularly shaped, and we'd like to go ahead and create elements that will sort of follow the curve. Okay, so we're going through a couple different examples and then a little practice thing here to work on. If you'd like to, before we go into the first assignment. So just kind of sort of hopefully drill some of these things home. So we're going to look at a couple different things that we've been playing around with a little bit. We haven't actually placing points on Revit curves. We'll just kind of look at that in terms of the point placement parameters. We'll also look at kind of the inverted side of it. Rather than selecting a Revit curve, how you can go through and just use X, Y, Z coordinates to create a curve. So you can do it mathematically to generate curves, or you can generate curves in Revit and grab the points. Either way, you sort of end up at about the same place. It just depends on whether you would like to drive it with a math or drive it by drawing geometry. Okay, but then we're going to take a look at an example of a very kind of unusual and interesting shape, an expanding spiral or helix, which I mentioned is sort of the form of the Guggenheim Museum in New York, which is actually like a really neat form. It's pretty hard to model in Revit, but Dynamo makes it pretty easy. Okay. In terms of what we're going to be looking at, per the whole notion of the bag of tricks, these are the bag of tricks elements that we're going to our nodes that we're going to be working with today. In terms of getting geometry from Revit elements, there's a couple of different ones that we've worked with. There's curve element dot curve that pulls the curve geometry off of a curve element. Okay. There's also this element geometry, which is a more generic way of doing that, just for any element, pulling the geometry that defines that element. Okay? There's the whole notion of placing points on a curve. There's placing a point at a distance, so curve dot point at distance. That's for a given curve. You can specify a distance along the curve that will place a point at one distance along the curve. Okay? There's curve point at parameter. Curve point parameter says, hey, given a curve, we can assume the start is 0, the end is 1. The parameter is just relative points along the curve. And that tends to actually be more powerful because thinking about it as being the 0.5 point on the curve is more flexible than thinking about it being 3 feet down the curve. Because then as the curve reshapes, it's always kind of at the same relative position. So that's going to become a real big friend of ours. In terms of other things we're doing, we're going to play around with lists a little bit. We looked at creating lists where we sort of put several things together, item 1, item 2, and kind of make item 3. There's a couple of other ones that are sort of useful to us. List rest of items is, that takes the first thing off the list and it gives you item 2 through the end. Okay? Very useful when we're trying to take a list of things and connect the dots, because you take the first one and connect it to the rest of the items, which means connects 1 to 2. Then you can take 2 and connect it to 3, and then 3 connect it to 4. So if you need to kind of string things linearly, rest of items is useful. But you'll see it. Okay. List transpose, that's the whole idea. You have several different lists, and you just want to turn them 90 degrees so that the columns become rows and the rows become columns. Count uses the number of items in the list, and remove item at index. That's if you just want to get rid of some things. So if you want to get rid of the last item, for example, you can count the number of items, okay, then remove the last item. Interestingly, one thing to watch out for with list count and remove item at index. The last item is not the count, it's the count minus 1. Because the indexing is always 0 based, so item 1 is index 0. Okay, and that'll throw you, so watch out for that. That's a classic that gets us in trouble. So the first thing we're going to do is look at placing points on a curve. Okay, and in terms of what we're going to do, we're going to get something. We're going to select a curve by saying select a model element. We're going to cast that as a curve. We're going to pull the curve geometry out by using curve element. We're going to divide the curve by setting up a little code block to set up some points between 0 and 1 and the number of points. And then say, put some points at that parameter. Okay. And then we can place some geometry at those different points. But it's all about just, going through and whether it's geometry, circles, whether it's family instances, okay, individual family instances like desks or RPC beetles or whatever it is, or if we have several points, then we can start thinking about adaptive components that connect the curves. That's where we're going. Okay, so let's go to example 4.3, if you can. Head over to Revit. Let's open up 4.3 and see what's happening out there. Save that away, just so I have the latest version. Okay, so you'll see I have a curve out there. This curve is something I just drew in Revit. I drew it by actually sort of placing 4 different points. It's a little spline curve. If I want to, I can draw another one. Let me go through and draw some points. I'll just put them down on the placement plane right now. There's nothing special about 4 points. It could be 5 or 6 or whatever you want in there. Okay, and I'm going to make a curve out of them. I'm going to create a spline, turn on my 3D snapping. Well, can I do that? Nope, it's on level 1, so I guess it'll work. Okay, so I have some different curves hanging around here. Not too bad? Okay, so these are Revit-defined curves. They're supposed to mathematically define curves. They have x, y, z values, so I could drive x, y, z values to kind of deform that curve. But this will work for now. Let's go ahead and we're going to open in the Dynamo plugin, add in. The accompanying script, we'll go ahead and say open. Points on a Revit curve. Go for 1A. See if I can get this cleaned up. That looks a little messy right now. That looks like it was left over. Add dirty geometry. That's not look good looking. Did you get something, or you have the same error message in there?
I got something.
You got something. Let's see if I can try that again.
Are you opening 1A or 1B?
I'm opening 1A. Let me go and open 1B. Could be that I saved it incorrectly somehow. Sometimes when Dynamo is being messy, or even Revit's being messy, I just reopen things. Let's try it again. Because the fact that some of you got something, invalid Kent method, back buffer, looks like there's a problem there. So what I'm going to do is, since closing Dynamo didn't do it, I'm just going to close Revit and kind of reopen that. Let me go ahead and save this away, just in terms of my curves. I may just have too much stuff open or something that's confusing it. But I've learned, and I think it's a good general truism with Dynamo stuff, like whenever things start getting a little bit flaky, you know, the best plan is just like restart everything, you know. With so much of the software, it's just buggy. And when you hit funny little memory leaks and stuff like that, the best thing to do is just kind of clear the palette and start over again. So don't spend a lot of time just beating your head on like Dynamo's bugginess. Actually, try this. I'm closing one at a time. Let's see if I can just exit and get it to do it that way. I was going to say, I want to close all. Well, maybe you do the call. Yeah, no, don't change that.
No, don't change that. Okay, try it again. Okay, so who saw error? Who didn't see error? Three good.
No error.
No error? Only me. It's just me. That's okay. That's reassuring in the scheme. I like to think that the file's not damaged, just something's wrong with Revit. Okay, let's go out here. Oops, there was the example, points on a curve. And finally, let's go back and see if we can open it Dynamo again. In Dynamo, you can start previewing what's going on in there. You'll see that it all starts with just this whole notion of selecting those curves and then just pulling the curve geometry off of the curve element. So let's see if we can get that. And last but not least, that's better looking. At least it has a grid. Okay, excellent. So, once again, closing Revit together. We're going to go ahead and grab a curve. We can actually grab a couple different curves if we want to, and just go through and extract the curve that way. Then what we're going to do is we have this code block. It's just going to go through and say that from 0 to 1, give us a certain number of points. Intersect those two things together and get some placement points. So it's pretty simple. This is a pattern you're going to use an awful lot. So if I want to get a single curve, what I can do is change and go out there and grab that curve. I think I got it. I have a little element over here. If you go through, and I can make this an auto one for right now because it's pretty small in terms of what I'm up to. You'll see the curve is drawn in the preview zone back there. If I pull down here, you'll see that there's a curve out of there. On the slider side, you'll see that right now I'm going 0 to 1 with 4 points. So I should have 0, 0.33, 0.67, 1.0. Again, watch out for that. You know, your intuition says it should be 0.25, 0.5, 0.75, and 1, but that would be 5 points. Okay, so if you want to, that's fine too. What I'll do is I'll take that curve, I'll take that list of values, those parameter values, and that'll give me a whole bunch of XYZ points. And if you want to, take a look. You can go back to your geometry and actually see what's going on back there. Zoom on out a little. Now, those points are useful. There's 5 equally spaced points along that curve. We can do things, we can put things on them. We can put geometry on them. For example, the circle that we've been using, and that's just sort of dynamo geometry. We can put spheres on them. We can put Revit elements at those points. Really, whichever way you want. Yes?
How can you have 5 points?
Oh, because I changed the parameter from 4 to 5.
Oh, I
I was sneaking around over there and just thought that might be easier to understand, so that's fine. So in terms of putting that geometry out there, if you want to try just putting the circles out there, what you can do is grab those points and just pull it as the center point of some sort of circle. And you'll see that what that does is just in Dynamo draws those circles. It doesn't actually do anything in Revit at this point. Okay, because that's just a piece of Dynamo geometry. See, I'm getting a little preview over there. That's because I'm saying preview things in the Revit environment. You'll notice that there's sort of an interesting thing going on here. The points which define the curve are independent of the points that I'm placing on the curve. And that's kind of a useful distinction. So even over here, if I move that point, for example, the curve is being redefined, okay, but the 5 points, it's sort of an independent notion. So your definition points and your placement points being two different things. That happens an awful lot. Okay? So we got some circles. If you got circles, let's go ahead and do the next thing, which is saying, let's go ahead and put spheres in instead. Spheres are really going to take those same points. What do I want to put in there? For the family type, see if I have spheres in there. I have boxes. I have cylinders. I have a sphere. I have a sphere down there. Let's put those in there. And again, that won't change the dynamo geometry, but it'll change what's going on over there in Revit land.
Are those masses?
It depends on really what type they are. These are mass spheres.
Okay.
Okay. They could also be generic object spheres. Okay. And now because I have it set up this way, in theory, if I go through and drag that slider, I should get either fewer or more of those. Okay, let's go ahead and do something a little bit different. As long as we're in here, that'll be useful to us. How about this? Let's go ahead and grab that other line too. Okay? So, as long as you're hanging out in here, let's go ahead and just copy this part right here and paste. I'm just going to grab that section and then go out and say change, and change that to be the second curve. Now, this is a little bit of list management for you, okay? I got the two different curves. One of the curves being operated on, the second curve is not being operated on. Okay. If I would like to do all the same operations on the second curve in addition to the first curve, I'm feeding it a single curve and it's doing all this stuff. I could feed it a list of curves. Okay, and it'll do the same thing to all the curves. And there's sort of an advantage to that. If you want to put the same spacing of points on all the different curves, it might be easier to kind of keep this in one block and do it to the list of curves as opposed to doing it 4 or 5 different times and copying it over and over again. So to do that, what I can do is just make a list. That's always list.create. I'll take one curve, and I'll take the second curve, and then I'll pull the list down so it's feeding it a list of curves. Now, one thing to watch out when we work with these lists, and we do it that way, is just this whole notion of, okay, I got these 5 different points. I'm using the cross product lacing. The cross product lacing is saying, take whatever this list is of parameter points, take these curves, and do them to both. It's crossing them, as opposed to doing shortest or longest. Okay, so that part's good. Although it looks like on the tail end, though, I'm a little messed up. I'll call this the Andrew observation. The problem is, what I have going on right here is I have these 2 different lists of points. I'm saying go through and do the center point radius and just stuff like that. But since it's a list where the points are contained in a list, if I want to get the circles and I want to get the spheres at all the points, what I'll do is I'll flatten the list. And I'll always give you credit for that just because I missed it. And it's like it's a really useful thing to remember to do. So when you have things like this, what I'll do is I'll just flatten the list. you'll see that's going to go through and construct just a whole bunch of points in a single flat list. And instead I'm going to feed that flat list up as the center points of the spheres and the center points of the circles.
Is there a way to include like a comment in this?
Yeah. Let me see what I broke here for just a second. Oh, it's my family. I broke that. So if you would like to have a note, do it two different ways. One way is I tend to sort of clump things together like that, just to sort of group them. But if you just like the idea of putting a note in there under, oh, I got to find it in here. Where is it? Under Edit, Create Note. There it is. Control W. Yeah, that's just a little text piece. Okay, and remember to flatten lists when points encased in hierarchy. Is that sort of what you have in mind? Some sort of like just a note comment or?
Yeah.
Okay.
Exactly.
See, we're doing pretty good over there. We have 4 on one, 4 on the other. You're doing pretty good. We actually got the origin of really what we need here, because we got all these points. They're doing pretty good here, doing pretty good there. Let's do this. What if I wanted to go one step further? What if I actually wanted to go through and connect between those different spheres? I wanted to go ahead and put our little tube element in there. Might have a little helical, like a DNA model or something like that. Okay? So let's think about how we could do that. Can I do that? I think I can. Let's see what's going on. I think what I'll need to do is over here in my Revit model, I'm going to have to do a little bit of an insert. And I'm going to load a family. I'm going to load my little 2-point tube. Now, in case your 2-point tube didn't quite work out, I think I have one hanging around here under 4.2. I have tube 2-point there, so you can grab one there. Okay, so it'll be available to us now. Now what I want to do is basically grab sets of points. I want to go through and I got on each of these different lines these 4 points. So what I want to do is actually grab the first point in each line, the second point, kind of pull them together, okay? And that will go through and give us the pairs we need. So let's think about that. So you might remember back over here when we put these curves at the parameter, we created these lists. List 1, 2, 3, 4, list 1, 2, 3, 4, 0, 1, 2, 3, 0, 1, 2, 3. What I really want to do is get element 0 with element 0. I want to get 1 to 1. Okay, what does that sound like? I like Dom's answer. I don't remember, but I know we can do it. Which is actually the way I usually approach this. Okay, so a list transpose. Because Claire is writing down every useful function and has the dictionary of. Actually, it is useful just to think about it as a bag of tricks. It really is. So I'm going to take this list, transpose it, and now I'm going to get pairwise.
What is the purpose of this function?
So again,
What does this function do?
it basically, it takes the 0th and 0th from both lists and combines them together. It takes the first and first from both and combines it together. So what's the easiest way to explain it? If you have lists that do that, so 3 groups of 4, okay, what it does is it makes 4 groups of 3. So it just always transposes it. So that's useful because what I wanted to do is currently those points are stretched out down the string and I want to kind of cut across the string. Okay, so that's why this is an all-time favorite. We do a lot of messing around with lists. Okay, when I want to go through and place an adaptive component, I always start with family types. Family types is the way I go out and grab families. So if I choose family types and I go my 2-point tube, okay, I'm ready to start placing it. Now, as opposed to saying place a family instance by point, for adaptive components, we say adaptive component by points. And then as opposed to a single point, it'll look for 2 different points or 3, whatever it wants. So we'll say adaptive component by points. So what'll I do? What I want to do is feed in the family type. Now for the points, this is one, unlike the flattening, this is one where you really do want them grouped together because it wants to think of, in every list, all the points that are necessary to place a single instance of it. So I'll grab those. Cross your fingers, and let's see how we did. Check it out. Not too awfully bad. Yes?
So if I change this slider now, it will automatically add.
Try it. Try it. I hear a sense of play in your voice. And that is good, because if you change the slider, it should do that. The other thing that will happen is if you change the curves, if you go out there and grab the curve points and go deforming it, give it a moment to update itself, and it'll do what it's supposed to be doing too. So lots of cool stuff in that. Now, that's actually sort of enough to get going. Let me tell you, I won't get into the Helix thing, because the Helix is its own, if you want to look ahead, please do. Going through and defining a helix that expands is kind of interesting, because in a way it's like cosines and sines, that gives us a perfect circle. But you want to do something where it's not only the z is changing, okay, and actually it's expanding or contracting. So, we'll get to that next time, I'll show you that. But just to get you going for this weekend, if you want to practice with this a little bit, I'll go ahead and send out something that is a practice exercise. Let me show you what I had in mind, and then you can play with it if you want to, just to sort of get some practice doing this. Okay, what I'm going to do is open up, there is actually, under session 4, I get a little practice exercise. What we'll do is we'll give you this. This is basically, it's basically 4 lines. A line at the bottom, a line at the top. Let me shade this man a little easier. See what's going on? Where basically Dynamo is going through and doing 2 different things. It's putting points along the bottom. Okay, it's putting points along all the different curves. There's 4 different curves here to go through and place some things. And then we're doing 2 different things. One is we're grabbing the points between kind of pairs and putting these vertical elements in there. Okay, we're also going along the lines though, and actually on the line connecting first to second, second to third, third to fourth, doing a little adaptive thing like that. But the net effect of this is that you sort of can go through and create, I think of this as being railings on a bridge, but that could be all sorts of funny structural elements. But we'll go ahead and give you kind of something that looks like that to go through and play with. And, hang on. See if I can find it here. Go to add-ins. Open. You'll see the way of doing it is, hang on, I'll write this up for you so that you have something to play with. Where'd it go? There it is. It kind of does something very similar to what we did so far. What we did is we're basically selecting the 4 different curves. Okay. I'm basically pulling the curves out of them. I have sort of a number slider so that we can go ahead and make the points. So that's exactly what we just did in the last example. But then in the tail end, we're just doing, some different things. We're getting a couple of the different curves and transposing it. That's to go through and connect the things into the vertical elements. We're doing something else where we're getting the first item and the rest of the items, connecting them together. That's all about when you want to make a series of things along a single line, as opposed to like a cross. And we'll show you how that works. Actually, let me show you sort of an interesting notation that's just sort of very useful. The farther you go with this, the more you start looking for ways to sort of shortcut yourself.
Is this file in the folder?
It isn't, but I'll mail it out for you so you can kind of play with it. Yeah, when I do things like this and I put them all together into a list and operate them on a list, that's kind of good. It sort of is efficiency to do that. So if I change the slider, it affects all the different elements. That part's good. Just one thing to sort of watch out for, and then you'll see it in the file when you get it, is in terms of these curve points, you'll see there's 4 different sets of points. When I say list get out of an index and I feed it 0, 1, that's going to get the first list, or the 0th list, and the first list. So it's a way of basically getting 2 lists out of 4. So it's a list management thing, but you'll see it starts to get to be very useful. When you keep everything together in a big dictionary of all the lists, every once in a while you start grabbing out the ones that you're interested in. If I want to get 2 lists, if I want to get a single list, if I want to get the second and third, you can pull out the list that you want. Okay, so find a little piece of notation. I'll explain about it in the assignment or the practice thing. You can sort of have fun to play with. But it's you can go through and pull out specific pieces and then just grab what you want. So if I say of the 4 things get 0 and 1th, it's only going to get 2 things out. Yeah. And then with those 2 lists, we can do the transpose on it. So there's a leap in there, okay? But that whole notation is a little bit cleaner. So although it's a little bit of leap, I want to keep on showing you kind of efficient ways of doing it because it's just kind of the best practice to sort of get into. Okay? Beauty. Let us adjourn for today. Again, actually, yeah, so there's no real homework yet. The first homework assignment will come out on Tuesday. You can sort of think ahead a little bit. What you're going to be doing, you might imagine, is designing something like this. We're going to have you do, think of a little band shell or something like that. Like a little gazebo or something like that. Where using a little parametric design, a little bit of geometry, you'll sort of figure out a form that you would like to create and then place some adaptive components kind of using that geometry to create some interesting, you know what a band shell is? It's like a bandstand, something like that. Or you can do the Hollywood Bowl, any of those things. Just some sort of interesting geometric shape where we're going to use a little bit of geometry and a little bit of adaptive component to create kind of an interesting form that I can start pulling on sliders and start changing the form. Okay, beautiful. Okay, let us adjourn for today.